Hi dear students. So today we will discuss about stereochemical aspects of nucleophilic substitution reaction. So in organic chemistry, in haloalkanes and haloarenes, so this is one of the important concepts that you should know. Stereochemical aspects of nucleophilic substitution reaction. Before going to the stereochemical aspect, stereo means a orientation of atoms and bonds around the carbon atom or around the central atoms. So how the arrangement of bond is taken place. So to study that concept, it is a stereochemical and a nucleophilic substitution reaction. So such kind of orientation of bonds and atoms or molecules around the carbon before the reaction and after the reaction, so that we will going to study in this part. And in a nucleophilic substitution reaction, before going to the nucleophilic substitution reaction, you should know what is a substitution reaction. So substitution reaction, in a substitution reaction, if a nucleophile is involved, then it is called as a nucleophilic substitution reaction. So now, a substitution reaction is a reaction in which an atom or group of atoms will be substituted with the other. For example, so if you take a carbon associated with a different atoms and molecules or whatever it may be. So if an atom or a group of atoms which will be substituted, which will be replaced with other atom or a group of atoms. So substitution of atoms or a group in a molecule is called a substitution. In a reaction, if such a substitution is taking place, then we will call it as a substitution reaction. Example for the substitution reaction: methane will be converted into methyl chloride, in which a methane contains 4 hydrogen. One of the hydrogen is substituted with the chloride, so that it will become methyl chloride. Similarly, one more example you can give: a methyl chloride can be converted into methyl alcohol in the presence of aqueous KOH. See, dear students, so this is an example for substitution where methane reacts with chlorine and it will form methyl chloride. So where methane carbon contains 4 hydrogen atom, in which one of the hydrogen atom is substituted with a chlorine atom, so that the exchange, that the substitution will takes place, so that the hydrogen of the methane is substituted with the chloride to form methyl chlorides. Now let us see what is a nucleophile. So nucleophile is a negatively charged species. Our nucleophiles are nothing but the species which like a positive charge, which like the nucleus. Nucleophile means nucleus liking. So nucleus means what? It is a positively charged. So when you consider a positively charged nucleus or positively charged, a species which attracts or which like positive charge, it is nothing but it should contain negative charge. So whenever a species with a negative charge which likes the positive charge, which likes the nucleus, we call it as a nucleophile. So negatively charged species means it may be an anion. So any anion can act as a nucleophile. A nucleophile means an electron-rich species. So all these examples, that is a neutral molecules. So these neutral molecules will not have negative charge, but they will have a lone pair of electron which is not involved in the bond formation. So nitrogen contains a lone pair of electron, oxygen contains a lone pair of electron. So that whichever the species are neutral molecules which contain lone pair of electrons will also considered as nucleophiles. In general, the statement of nucleophile or definition of the nucleophile, we can say the species which contains electrons, which is rich in the electron rich species are called nucleophiles. Neutral molecules can also be a nucleophile due to presence of lone pair of electrons. When you consider an example of ethyl alcohol, so where the oxygen is present, which contains rich electron density. So graphical space filling model of ethyl alcohol, when you observe, the red part is observed as electron rich and the green part is neutral, and the blue part will be considered as electron deficient. So where you can see the presence of redness in the oxygen zone, where blue in the outer region. So it shows that the electron density is maximum, so that it can act as a nucleophile. That is because of the presence of lone pair of electron on. Nucleophilic substitution reaction follows two different mechanisms, SN1 mechanism and SN2 mechanism. Let us see what is SN1 mechanism, how it will take place. In SN1 mechanism, it involves two steps. So first step is formation of carbocation and the second step is nucleophile attack. So formation of carbocation means, so when you take an example of tertiary butyl bromide will dissociate to give tertiary butyl carbocation, will dissociate to give tertiary butyl carbocation with the releasing of a nucleophile. So first step involves two steps. First step being where the bromide will be released and the carbocation formation. So tertiary butyl bromide will be converted into tertiary butyl carbocation, which is stable one. The stability is due to the inductive effect of methyl groups and alkyl groups. And the second step is a nucleophile attack. So now a tertiary butyl carbocation is attacked by a nucleophile, so that it will form tertiary butyl alcohol. So in these two steps, a rate of the reaction always depend on a slow step of the reaction. In these two steps, a second step is the fastest and the first step is the slowest. So slowest step of the reaction. So which will determine the rate of the reaction. So when you consider the conversion of tertiary butyl bromide into tertiary butyl alcohol, the rate of the formation of this reaction, the rate of the formation of the product will depend on only one step. In one step, in the first step, what happens? Formation of tertiary butyl carbocation takes place. For that you need only tertiary butyl bromide. So that the rate of the reaction, even though it contains two reactants, but the rate of the reaction will depend on only one reactant. So therefore, this mechanism is considered as one represents unimolecular nucleophilic substitution reaction. Look, dear students, in SN1 mechanism, the tertiary butyl bromide, so it undergo two-step mechanism to convert into tertiary butyl alcohol. So in first step, the formation of carbocation takes place by leaving the bromide, and the carbocation formed tertiary carbocation, which is more stable due to positive inductive effect of alkyl group associated with the central carbon. When the nucleophile attacks, that is the second step of SN1 mechanism, and it will bind to tertiary carbon and form tertiary butyl alcohol, so a stable one. Let us see SN2 mechanism. In this SN2 mechanism, it involves two reactants for the rate of the reaction. So rate of the reaction depend on both the reactants. Therefore, it is considered as bimolecular nucleophilic substitution reaction. Let's take an example of methyl chloride. So methyl chloride is made to react with aqueous KOH and it will give methyl alcohol. So in this mechanism, methyl chloride, so the OH minus will attack the carbon and it will form an intermediate. So this intermediate dissociate and it will give product methyl alcohol. So this is SN2 mechanism where the formation of methyl alcohol from methyl chloride involves only one step. In this single step, formation of intermediate is the slow. So formation of intermediate is slow means, so formation, the rate depend on the formation of intermediate. The rate depend on the formation of intermediate. So formation of intermediate require two reactants. Therefore, the rate of the reaction will depend on both the molecules, so both the reactants. Therefore, it is considered as a bimolecular nucleophilic substitution reaction. Now, look into SN2 mechanism where the methyl chloride attacked by the nucleophile OH minus in the opposite direction. So it will attacks the carbon and it will form an intermediate. This is the position of the intermediate where the bond making is taking place between the oxygen and the carbon, methyl carbon, and bond breaking is observed in a carbon and the chloride. So the gradually bond making and the bond breaking takes place simultaneously at this place position, which is a very less stable. So we call it as an intermediate. So when these intermediate will dissociate, so the bond breaking will start continuously and gradually the chloride will be removed from the carbon, so that the methyl alcohol will be formed and leaving the nucleophile Cl minus chloride. So this is how a nucleophilic substitution reaction, that is SN2 mechanism, will take place in a single step. So the important concept that you have to learn from these mechanisms is one. So generally, tertiary carbocation or tertiary alkyl halide, tertiary butyl bromide will follow SN1 mechanism. When you consider SN1 mechanism, tertiary always greater than secondary than primary. So always tertiary will follow SN1 mechanism. It will not undergo SN2 mechanism. So why it is not undergo SN2 mechanism? That you have to find it. That you have to learn. Why? Similarly, when you consider methyl halides, so methyl halides generally undergo SN2 mechanism than SN1. It will not undergo SN1 mechanism. It will follow SN2 mechanism. Why it will not follow SN1 mechanism? This is the question. So when you find the answer, you will know the actual concept of why tertiary alkyl halides undergo SN1 mechanism and primary alkyl halide undergo SN2 mechanism. And primary will not follow SN2 mechanism, SN1 mechanism. Why? Tertiary will not follow SN2 mechanism. Why? That you have to learn. So it will going to be explained in the next session. Thank you. Bye.